Today we're going to be revisiting the whole subject involving solid bed mounts, because one type of bed mount that I did not use before due to certain technical difficulties was the aluminum bed mounts. Because the thing about them is that, yes, they are machined to a point where their variances between each other are very small, within the hundredths of a millimeter, making them perfectly suitable for solid bed mounts. And you would think that with them all being the exact size you need them to be, that you would just put them in place, tighten down your nut here for the screws for the bed, and call it a day. But that is not the case, because when you install these aluminum bed mounts, one thing you have to take into consideration is the Y-axis carriage itself is not nearly as flat as the hotbed that you're printing on. It's not built to the same tolerances. So even though the aluminum bed mounts are perfectly machined and are sized just the way you need it, they will not be perfectly level. In fact, you're going to be very far off, because the Y-axis carriage is just not flat, and it was never meant to be super flat. It was meant to allow you to adjust the level of the bed with something like this, a metal spring, so that you can fix the uneven nature of the bed. That being said, there is a solution, and I had waited for a long time to get it, because it comes from AliExpress. And my solution are shims. These are M4x8 shims, meaning their internal diameter is 4 millimeters, their external is 8 millimeters. And they are what I use in order to re-level it out. So instead of adjusting a spring up and down, what I do is I put these aluminum bed mounts in, do a bed level test with my ABL using the Octoprint Bed Mesh Visualizer, see what part of the bed needs to be raised up, or, well, you can only raise it up in this case, and put shims on those spots to flatten it out. Now, what we found is, in place of these shims, you can use razor blades. And that's what we're using on here. This was our test bed, and believe it or not, it worked out quite well. That being said, the razor blades actually are not as thin as my shims. So this razor blade is slightly thicker than 0.1 millimeters, and we measured that with my digital calipers. That's pretty good, but they're not consistent like these shims are. These shims are always consistent. Now, you would think that at this point, all you have to do is raise up the corners that are too low with the shims, put your nut back on the screw here with the little wheel, and you're good to go. Well, no, you're not. Actually, you've got a long ways to go. And it's a bit of an annoying process, but it is worth it once it's done. You see, the problem with shims that are this thin, and these are measured at 0.1 millimeters exactly, is once you compress these shims, meaning when you screw this nut back on the bed screw, that 0.1 millimeters becomes slightly thinner. So you can do a measurement before compressing them with these little wheels, and you would think, aha, I got a perfect bed level. Everything is super, super flat. But the moment you screw everything down nice and snug, your bed level is no longer level. And it can get pretty wild pretty quick, because some of these bed mounts needed more than just 2 or 3 shims in order to get them to a point where they were the same height relative to each other after shimming. So The thing you have to do is not only do you have to shim it, but you have to compress it, then measure, and then re-shim after that measuring, and then compress again, and then measure again until everything is perfect. So yeah, it's way more tedious than I initially imagined it would be. Because you would think, okay, if there's 10 millimeters all exact on these, and there's maybe 0.2 millimeter difference here, 0.1 millimeter difference there, something, yeah, you put 2 shims there, 1 shim there, and you're nice and flat, but that's just not how this works. On top of this, there is another very important point to note. These shims are quite small. I could not find anything with an M4 internal diameter with a wider external diameter. Unfortunately, these are as big as they get for the purposes that I ended up using them for. And because of that, if you put the shims above the spacer, what you've essentially done is you've created a point that was nice and big before and made it really small. And the problem with that is you go from a large flat surface to a very small flat surface. And that small flat surface essentially makes a point. And if you make a point, then you might warp your bed a little bit. That's not good. So when you put these on, put the spacers so that they are touching the hotbed, but put the shims so that they are touching the y-axis carriage. Because if you don't do that, you're going to end up warping the bed when you tighten everything down. So, once you get all that done, is it worth it? Yes, because once everything is set, compressed, and level enough that your ABL can handle any sort of minuscule variances, that's what the ABL is there for, and you get nice flat first layer prints, you really don't have to adjust anything else from there on out. It is set, it is done, it's not really going to change. So even with the expansion and contraction of the metals, because yes, your bed is touching a full metal bed mounts, I found that it's not enough heat to transfer through this to make any real noticeable issues. So, all that to say that yes, these are worth it if you shim them properly and compress each time and measure, compress, shim, measure, compress, or measure, shim, compress, measure, shim, compress, yada yada. You're going through this process several times in order to find the perfect level. Now, the reason I think it's important to use proper shims instead of razor blades is that these shims are the exact internal diameter that the external diameter of these screws are. So even though they are much, much smaller than the spacer themselves, because that internal diameter on the shim is the same as the external diameter of the screw, they will not move. They will stay in place regardless of the fact that they are different sizes. So it's not as simple as I was hoping it would be, but it is still very much doable. It's just really tedious. So hopefully that helps if you were considering going this route. Again, it's worth it if you're already the kind of person who's doing stuff like linear rails on every axis. You know how tedious getting those are to be perfect can be, and these are the same. It's the same concept. You've got a solidified system that is not going to change once it's put in place. It just takes a while to adjust.